Hey guys, so tomorrow what I'm going to be doing is giving you some booklets from the Pearson textbook, and basically these booklets are going to be talking about indices in more complex types of situations, I guess. So not necessarily as straightforward as the Dwyer textbook. So we're going to be looking at using all of the math, okay, that we learnt in relation to index law 1, 2, 3, 4 and 5. I'll just shut the door. We're now going to be using those laws, but doing it with unknown variables. So I was having this conversation with a student last week. So we use like X and Y and A and D and Z, okay? We refer to those as pronumerals, and what they effectively are variables that we don't know what they are yet, okay? So it really depends on the situation. So we're going to be doing this one first, and in this one you can see that D here is what we'd refer to as the base. So we've got D as a pronumeral, and we've got D over here as well. These numbers at the front are what we refer to as the coefficients. Okay, so my coefficients would be 3 and 2, and this little 3 obviously is to the power of 3 and to the power of 2. So we would refer to this entire collection of numbers and variables as an expression. Alright, awesome. So I'm going to simplify this expression, okay? Because this can be simplified further. Now what I'm going to do in order to simplify this is to make it a bit easier for myself, okay? So what I'm going to do is, even though here it says 3d3, even though we can't see it, there is an imaginary times here. So 3 times d3, okay, times 2, d to the power of 2. So once again, there's an imaginary times here. And that helps us to actually, it simplifies this a lot, so we can actually see how we can move these around in order to solve them. So if I rewrote this, 3 times d3, it's d to the power of 3, times 2 times d to the power of 2, okay? I would encourage you to do this as your second line. So here's your first line, here is your second line. And in addition to that, what I'd then like people to do is to sort of rearrange this expression so that it makes a bit more sense. So maybe you might like to have your coefficients on one side and perhaps your unknown variables on the other side. So what I'm going to do is rearrange this, okay, so that 3 times 2, so they're next to each other. I'm not solving anything yet, so 3 times 2 times d to the power of 3 times d to the power of 2, okay? So once again, I haven't simplified anything yet. All I've done is just added in a few timeses and rearranged, moved the 2 here to here. Okay, so now what we're going to do is do this in steps. So firstly, 3 times 2, well 3 times 2 is obviously 6, alright? And I would encourage people at the early stages to consider I guess simplifying one part at a time, so rather than doing the whole thing at once. So I still haven't looked at this part yet, so I'm going to leave that and move that down. So times d to the power of 3 times d to the power of 2. Okay, now what I'm going to do here is my base is the same, and obviously my exponent is different. So this goes back to index law 1, where effectively what I do is I add my indices together. So new line, 6 times d to the power of 3, add 2, okay, equals 6d5. Alright, so this simplified would be the same as this. This simplified would be 6d5. And as you can see here, all I've done in the first line here is I've added my times in. Then I've just moved my 3 and my 2, okay, and made it a bit easier for myself to move those to the left, okay. And then here, that's actually when I've started to simplify it a bit more, okay? So where I've actually used, okay, well 3 times 2 is 6, I've done that. And I've kept these here, I've dragged those down. And then I'm going, okay, well 6 times d to the power of 3 plus 2. And then that there is where effectively I've actually added my indices together using index law 1 equals 6d5. This one here, we'll do this one together now too. So leave that on the board. Okay guys, so like you guessed it, what I'm going to do first is put in my time symbol. So I'm going to go 5 times b to the power of 4 times c to the power of 5 times 6 times b to the power of 3 times c to the power of 2. Alright, so I haven't done anything actually at all. All I've done is put in my imaginary time symbols here. Now what I'm going to do on my next line is just kind of, I guess you could say, move them around so it makes a little bit more sense. I'm going to put my numbers together, I'll put my B's together, and I'm going to put my C's together, just so I can make more sense of it. So I'll go 5 times 6. Alright, and then I've got my b here, b to the power of 4 times b to the power of 4 times b to the power of 3 times, oh, got that one, c to the power of 5 times c to the power of 2. One thing that I do as well, just to make sure I've moved everything down to the next line, is I tick them off. Yep, I've got my 5, I've got my 6, it's there. I've got my b to the power of 4, I've got my b to the power of 3, I've got my c to the power of 5, and I have my c to the power of 2. Yeah, they're all on my next line. Okay, now the math starts. So 6 times 5 is 30. Okay, and for this one, rather than, I guess, doing one bit at a time, okay, so using index law 1 to go b to the power of 4 out of 3 on that line, and then solving this, simplifying the C parts on the following line. I'm just actually going to do it all on the one line, because as you can see, it can get quite long when we're moving down. Okay, so now I'm going to go times b to the power of 4 plus 3, okay, and times c to the power of 5 plus 2, and then on my next line I'm going to go equals 30, okay, b7, c7. Perfect, so this, okay, is probably, to some degree it's an expanded form, but it can be further simplified to this. So 30, b to the power of 7, c to the power of 7. I hope this helps. I'll do some more.